And my next guest is Sohan. Welcome, Sohan.
Thank you so much.
And Sohan, so you're obviously a speaker at this conference.
Yeah.
And you're going to speak about serverless WebAssembly.
Correct.
What is it?
Okay. So let's break that down, right? Let's go with serverless first. I think in cloud computing, we've seen like different shifts. We've gone from the good old days of having a server room. I think few of us might remember that. To things like EC2, where you had a virtual machine running the cloud, to containers, to then this phase of serverless, where you essentially, as a developer, write only your business logic. You do not focus on maintaining servers. You do not write server daemons and processes. And it's completely event-driven, right? So that is the serverless part. WebAssembly is a bytecode format. It was invented, as the name suggests, for the web to make, to give you access to be able to write code in like Python and Rust and C, convert that into this bytecode format that could run anywhere, right? So it could run on any OS, it could run on any platform, on any architecture, everywhere, right? So the combination of serverless and WebAssembly seems to work well for building, distributed computing, but also for cost savings and sustainability, which is what my talk is about.
So this is an interesting aspect,
Yeah.
right? So cost saving and sustainability. How serverless WebAssembly actually helps? I think let's kind of build it up a little bit.
Yeah.
Recently, we hear a lot of, I don't want to say complaints, but kind of concerns about the cost of cloud.
Yeah.
Right, so we heard there was some very popular and how should we say viral takes that hey, the cloud is just so expensive right now. It actually makes sense to repatriate, I love the term, the services back on the premises of the companies.
Right.
And I think this becomes a very big topic, and you're addressing it how?
Yeah. So I'll try and maintain this conversation specifically to serverless and cost savings there, because I think cost saving in the cloud is like a huge topic and we'll need the entire day to talk about it. Right? So I think the model of serverless right now, if you look at Lambda or Azure Functions or Google Functions, is in such a way that it actually ends up being very expensive if you want serverless in the way it was spoken about. So for instance, there's an event, your serverless function is called, something happens, and an event is sent back. But the way serverless is written now is that there is something called a cold start, right? Because that function sits dormant on a virtual machine somewhere. So there is a finite time, say between 250 to 500 milliseconds for that function to start. And now speed is of the essence. We all need like fast, like instant, no latency, right? So what people do to keep that function warm is to keep it warm. And by that I mean by sending like a ping to that function every now and then, or keeping that instance warm.
But this is where the cost comes in,
exactly.
right? Because you pay for serverless, you pay per cost.
Yeah.
And if you want to keep your function warm and you send those pings, this all adds up to your cloud bill.
Exactly, right? And purely because of the way serverless is structured right now, that's what actually happens. Our theory is essentially that with WebAssembly, because it was designed to be platform agnostic, architecture agnostic, and it was designed to be performant, right? Whoever built WebAssembly as a standards built it to be performant. You can reduce that cold start time to under 1 millisecond. So you're saving on not keeping it warm. It will do its thing that way. And you don't need to be tied into one hyperscaler, right? You can actually build a distributed system that is completely event-driven, and it doesn't need to be tied into one provider.
This is very cool, and this brings me to kind of an overall theme of the Build Propulsion Lab, which is developer productivity.
Yes.
And I think there are clear benefits in using WebAssembly for developer productivity as well, not only for sustainability and cost saving, because, for example, for starters, you don't need to implement those pings, which you'd rather not to, but also the portability is also very important because you don't need to rewrite your Lambda to different platforms.
Yeah, so once you have like a WebAssembly file, you can swap out the underlying infrastructure from, say, ARM to AMD, and it will still work, right? Because that is, again, how WebAssembly was designed. In a way, a way to think about it is similar to the JVM, where you write a Java file and a JVM runs in different places, and that can run anywhere, right? So it's a similar mental model. It's just that WebAssembly doesn't belong to a certain company. It's a general piece of technology, so it's not proprietary. So you can literally run it on everything from a Raspberry Pi to like an EC2 running somewhere to a Kubernetes cluster that you already have.
Yeah, we can argue here about the licensing of Java, not belonging to a certain company, but we won't go there. I think as Java was the major breakthrough in developer productivity back in the 90s when it appeared, and it affected tons of different, the future of IT and how people perceived what developer productivity is before and after. I strongly believe that WebAssembly is something as paramount in that, and that's kind of the next step in developer productivity because it's portability as well.
Yeah, absolutely.
All right, so I do have a technical question, and you mentioned that WebAssembly helps with the warm-up time of Lambda. How does it does that? One can say it's just the packaging, so how does it help?
Yeah, so again, just to clarify, it's not with Lambda specifically, because right now Lambda doesn't support WebAssembly, but you could run it, but you could run it as a serverless thing, like in using like different tools and products out there. So it works and it's so fast because it was designed to be performant. Right, like the instruction set is reduced to begin with. The way memory is allocated is reduced, and it has like a shared linear memory, which makes it faster on startup time. So the very way it was designed ground up was for it to be like extremely performant, which helps with this startup time. The interesting thing was it was designed for the web, but all the features that it was designed for actually make it ideal to be run on the server side, and hence, now people are slowly trying to like do that on the server side.
Yeah, I think WebAssembly by now is just a legacy name, right?
Yeah, exactly.
That speaks about how it was supposed to be the compiled JavaScript, right? Or everything compiled to JavaScript, but now it's obviously can be used anywhere. Sohan, thank you very much.
Thank you.
It was a pleasure. It was very interesting. We are looking forward for your talk to hear more details about that. And you all, folks, stay tuned to more episodes of Build Propulsion Lab at Swiss Cloud Native Day. And see you soon.